Hello, this is Mr. C and we're going to do some more difficult exponential equations. Before we start working on this equation, I would like to review simple rules of exponents. One rule that we're going to need to solve this equation is product rule and quotient rule. So if you remember, if I have polynomial with same base, let's say x to the third times x to the fifth, and if I'm multiplying, this will be x to the power of 3 plus 5. So by the same token, if I look backwards, so if somebody gives me exponent says x to the power of 4 plus 3, well, I can say that's same like x to the power of 4 times x to the power of 3. And we're going to use this trick in order to rewrite parts of this problem, especially this part here, x plus 1, x plus 1, and x plus 1. So before we do anything, I want you to be able to see that this part right here, 9 to the power of x plus 1, you can write that as 9 to the power of x times 9 to the power of 1, or just 9. So 9x times 9. Or if I want to, I can switch those around and just say it's 9 times 9 to the x. I can do the same thing with this here, 4 to the x plus 1. So I can write that as 4 to the x times 4 and switch it around and write that's 4 times 4 to the x. Okay, now that we have these ingredients, let's go and solve this equation. So in the first step, I will just write things that I know. So 3 stays the 3, 4 to the x power, plus, and now we're going to use our little trick, and I will rewrite 9 to the x plus 1 as 9 times 9 to the x. That all equals 2 times 3 times 4 times 4 to the x minus 9 times 9 to the x over 4. Next thing I should do is distribute. So 3 times 4 to the x, then I have 3 times 9 times 9 to the x, so this is going to be 27 times 9 to the x, and that equals 2. 2 times 3 times 4. That will be 2 times 3, 6 times 4 is 24 times 4 to the x. So 24 times 4 to the x. And then minus 2 times 9 is 18. So this will be 18 times 9 to the x over 4. Well, what I'm going to do here is I will group like terms. So here I have 3 times 4 to the x, I have 24 times 4 to the x, and then I have 27 9 to the x, and then I have this negative 18 over 4 times 9 to the x. So what I will do, I will put all my 4 to the x on one side. So I'm going to do 24 times 4 to the x, and I'm going to bring this 3 times 4 to the x to the other side, so minus 3 times 4 to the x. as far as this fraction here is considered, well, first let's rewrite 27 times 9 to the x. That stays, and it's plus. And then we'll deal with this fraction right here. Now, on the side, I want to simplify. So we have negative 18 over 4. I could divide. So negative 18 over 4, I could divide both by 2. So negative 18 divided by 2 is negative 9. And then 4 divided by 2 is 2. So that's negative 9 halves times 9 to the x power. So I will take this fraction and I'm going to bring that over to the left. But because it's negative, I'm bringing it to the left. It's going to be positive. So it's going to be positive 9 halves times 9 to the x. Well, now I could factor things out. So on the left side, what I can do is I can take my 9 to the x and I could factor that out. So I'm going to have 9 to the x times 9 halves plus 27. And then on the right, I could go ahead and factor 4 to the x out. So I can have 4 to the x times 24 minus 3. In the meantime, let me solve this fraction here. So we're adding two fractions. So we have 9 over 2 plus 27 over 1. You multiply the bottom, so you get 2 times 1 equals 2. And then you cross multiply. 1 times 9 is 9. Plus 2 times 27, that's 54. 54 plus 9 equals 63 divided by 2. So now I have 9 to the power of x times 63 divided by 2 equals 4 to the x times 24 minus 3 is 21. Now we're getting closer to solving this equation. So as you see, I have something with x exponent on the left and something with x exponent to the right. So what I need to do is put this on the same side. So I'm going to divide everything by 4 to the x. So I'm going to take that 4 to the x, put it under 9 to the x, and I'm going to have 9 to the x divided by 4 to the x. And now I also need to divide by 63 over 2. So I will take that and put it under that 21. So that equals 21 divided by 63 over 2. Now I will go ahead and simplify. So I can rewrite this fraction as 9 over 4 all to the power of x. And then this here is division. So 21 divided by 63 over 2. That's same like 21 times the reciprocal of this bottom, which is 2 over 63. So I'm going to get 21 times 2 is 42 over 63. I can simplify both numbers. I could divide this by, let's see, by 7. So 42 divided by 7 is 6. 63 divided by 7 is 9. So I have 6 over 9. I could still simplify that. I could divide this by 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. So this is really 2/3. So I can write that here, 2/3. Now the question is, how can we get our base to be same? Well, I need somehow to get 2 and 3 right here. So if I think about it, 9 is 3 squared and 4 is 2 squared. so I can rewrite my fraction, and it's still to the x power. So I was able to get 3 and 2, but 3 is in the top and 2 is at the bottom. So now I need to think, how can I rewrite these 2/3 to make them 3/2? Well, if you want to have something upside down with a fraction, you need to put exponent, negative exponent, in this case -1. So if I put 3/2 here to the -1, that's same like 2/3. And the last thing, we're going to use rules of exponent here. So this is 2 times x, and this is 2 times x. So I can rewrite the fraction as 3/2 to the power of 2x equals 3/2 to the power of -1. And now I have what I wanted. I have same base, 3/2 here, 3/2 there. And the only thing I need to do is now to compare exponents. So if these two bases match, then the exponents must also match. So now I know that 2x over here must equal -1. And that's a simple equation. We divide by 2, so x equals -1/2. Please go ahead and do this problem many times until you're comfortable and understand what's going on. And then when you can do it on your own or with minimal help, you know that you've learned this. Because problems like this, they use many of the rules that you need to memorize. And if you do enough of them, it will make you more comfortable with simpler problems.